Question 30 reads, which of the following equations describe a circle with the radius 10 that passes through the origin when graphed in the xy plane? And the origin is just 0, 0, if you didn't know already. The coordinates 0, 0. Well, in order to answer this question, we need to know the formula of the circle of the equation or the circle equation. We need to know the circle equation, and that's in the form x minus h squared plus y minus k squared equals r squared, where r is the radius and coordinates h comma k right here is the center of the circle, right? And if you notice, all these answer choices are in this format right here, in the circle equation. And so what the question is asking for, they're giving us equations for this scenario, right, with a radius 10. And so we know automatically that our circle equation on the right hand side should be 10 squared. If I have stuff here, on our right hand side it should be 10 squared because the radius is 10, and we know in the circle equation on the right hand side is the radius square, and so 10 squared, which is just 100, right? And so right off the bat we can take off answer choice A, because on the right hand side it's just plainly 10, which is not correct, right? Then the question goes on to say that if the circle, there's a point 0, 0 that is in the circle, right? Describe the circle with the radius 10 that passes through the origin, right? So what that means is if I have a circle like this, and this is 0, 0, and that circle is going to be something like this, or maybe I'm not too good at drawing circles freehand, but it looks something like this, right? And so usually how we deal with these questions is that we take this coordinate and plug it in to all these answer choices and see if the equation is true. That's how we do it, not just for circles, but for whenever they ask us to prove if a coordinate lies on a graph, we have to plug that coordinate into the equation and see if it's true, right? And so that's what I'm gonna do here. And so if I plug in, let's look at B, right? I'm gonna plug in 0, 0 for x and y. So 0 minus 5 squared plus 0 plus 5 squared equals 100. Well, 0 minus 5 is just minus 5. So minus 5 squared, that's 25, plus 5 squared, which is 25 again, equals 100, which it doesn't, right? It does not equal 100. And so B is wrong, because when I plugged in the coordinates 0, 0, the equation is not true. Okay, let's look at C. If I plug in 0, 0, 0 minus 10 squared plus 0 minus 10 squared equals 100. That's what they claim. Well, 0 minus 10 is minus 10, so minus 10 squared is 100. Again, 100 equals 100. That's very wrong, right? The 200 does not equal 100. And so again, C, when I plug in the origin, coordinates of the origin, this equation is not true. And so that must mean our answer is D, but we can just check once, right? So 0 minus 5 root 2 squared plus 0 plus 5 root 2 squared equals 100. That's just minus 5 root 2 squared plus 5 root 2 squared equals 100. When we have the exponent 2, it applies to both terms of the what's inside the parentheses. So it becomes minus 5 squared root 2 squared plus 5 squared into root 2 squared equals 100. Minus 5 squared is just 25. Root 2 squared is just 2 plus 5 squared again is 25. Again, root 2 square is just 2. And so equals 100. And that's true. 25 into 2 is 50. And 25 into 2 is 50 again. So 50 plus 50 equals 100. And so our answer is D.